Right, my amazing students, we are going to check my sound and just make sure my sound is okay. Oops, my sound is completely off, so hopefully that will be good. All right, so what we're doing is 6.3 and 6.4, which are a little bit more complicated, and I wanted to give you a good video of these. So we're going to go through them very detailed here. We have a system. Now, anytime we have a system of equations, that means we have two, sometimes more, but right now we're just dealing with two equations that we have to solve simultaneously, which means at the same time. And we're going to see that if there is a solution, these two lines are going to cross at some point, and that point where they cross is the solution. Okay, now notice it says, note that you can also answer no solution or infinitely many solutions. Okay, now we've talked about this in the Saxon book. When it's no solution, you have two, oops, that doesn't look very parallel, does it? You have two parallel lines when there is no solution. Two parallel lines. So this one would be no solution. They're never going to cross. Therefore, there's never a point that will solve both of the lines. If we have an infinitely many solution situation, that means that these two lines are actually the exact same line. So if they're same line, I hope you're going to be taking real good notes on this, because you're going to be using these notes to do 10 problems on your own. I'm going to go through these 10 problems in great detail, and then you're going to have 10 to do on your own. So we've got same line means infinitely many solutions. Infinitely many solutions means they are the same line. And no solution means that they are parallel lines. The only ones that have a solution are two lines that cross in one point. So now, how do we figure out this? First, it says graph the system and write its solution. So on this one, we're going to solve, most likely, by graphing. So let's go ahead and try to do that. There's several ways we can solve, and one of them is by graphing. Y equals 1/2 x plus 1. So let's look at this one. Remember, y equals mx plus b is our slope-intercept form of the line. And this first line is in this form. Y equals 1/2 x mx plus 1 plus b. So on the first line, so we'll just say line 1 is slope is 1/2, and the y-intercept is called the b term is 1. So let's graph that one first. So we're going to start where the y-intercept is 1, right here. And then from there, we're going to go up 1 over 2, up 1 over 2, up 1 over 2, and put a point. 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 Now I'll come back and draw a line through there shortly, because I'm pretty sure that my line is not going to be just real super straight. I'll do my best there. Okay, so down 1 over 2, so that's a point. Down 1 over 2, so that's a point. Okay, so here's my line. Okay? Now, this was line 1. Line 1. Now, let's look at line 2. Line 2 is not in slope-intercept form, but we could put it in slope-intercept form pretty easily. We could get the y by itself by adding 2x to both sides. So let's do that. Let's add 2x to the left, and let's add 2x to the right. Okay, so we're going to have on the second line y equals. These two are going to cancel. We're going to be left with the y equals, and then 2x plus 7. 2x plus 7. Okay, so now we have a 7y intercept right here. So let's go b equals 7, and slope is 2. This is line. Okay, so let me get this lined up. Okay, so another video failed, and I'm trying to get this done. So this is line 2. We just did the y-intercept and the slope, and remember that we went with the slope, it was 2 over 1. So let's start, before my video failed, that slope was 2 over 1 because of that right there. Now, I'm going to get a different color and show you something because it's really cool. So let's go with 2 over 1, which is your rise over your run. Now, the rise, remember we start at a y-intercept of 7 because of that 7 right there. So y-intercept of 7 is right here. And then we're going to do a rise of 2 and a run of 1. So from here, we're going to rise 2, run 1, and put a point. Rise 2 and run 1 and put a point. But then we're out of space. So we come over here and we change both these signs. Negative, negative. So now negative 2 is a drop. So we're going to drop 2 and go backwards 1. So we're going to go back to our y-intercept. Drop 2, go backwards 1. Drop 2, go backwards 1, and put a point. Drop 2, right there. Go backwards 1. Drop 2, go backwards 1. Drop 2, go backwards 1. Okay, and now this line intersects the other line right there at that point. And we look really closely at that point. And that point is -4, -1. But we never just stop there and take that for fact without going back into the original equations and plugging in -4, -1 to see if it really is the solution. So we come back here, we plug in a -4 and a -1 for the y, and we check. So 1/2 of -4 is -2, and -2 plus 1 is -1. So the first line checks. Now we go to the second line, and we have -4 for x. So we'll put a -4 right there for the x. We have a -1 for the y. And we get -2 times a -4 is a +8. Minus a 1 is 7. So there's another check. Both lines check. And the solution is -4, -1. Okay, so let's go to the next one. Now on this one, Let's see if I can make this any bigger at all. Well, I did put the answers in there, so hopefully that'll work. It says 3 systems of linear equations are shown. For each system, choose the best description of its solution. And if the system has exactly one solution, give its solution. Now, this system right here is graphed as a single line, which means that line 1 and line 2 are exactly the same. In this situation, these are infinitely many when there's just one line. Okay, infinitely many solutions. Infinitely many. Okay, and then let's just make our little note over here. If we have a single line, it's infinitely many. Because they are actually the same line, infinitely many solutions. If we have parallel lines, it means they never ever touch, so that's no solution. And then if we have 2 lines that cross at one point, that is the one solution. The one solution is that point. So now that we know that this one is infinitely many solutions, which is right there. So you just bubble that. And then this one is one solution, which is right there. So you bubble the top one, and the one solution is 1 over and 0 up. So that point is 1, 0. And then the 2 parallel lines is no solution. The system has no solution. So if you know this over here becomes very simple. Okay, so now you can see I've already done all this because I made the video and it failed. So now we're going to do it again. So here we have the problem. And we're supposed to 2 lines. We're supposed to use substitution to solve. Now, substitution is where you take one of the lines, you solve it for one of the variables, and then you slide that into the other line. So here, this one right here, the y is already by itself. So we're going to use the y for our variables. So we'll get another color. So we have solved this line for y. And now we're going to take the other line and slide the first y into the second y. Okay, so now we're going to write that second line as, we'll make a little bit bigger and make it a different color. Okay, so we're going to write this second line is our main line, and this one up here is going to be the subline. Okay, so we've already decided we solve for y, so negative 4x plus 5y. Now notice I took the y out and I'm putting in the substitution for y is equal to negative 31. So I'm writing this equation down, and then I'm substituting the y, which was right here, 5y, with 3x minus 15, which is y equals from the first line. So then let's make a note. So the first step in substitution is to get one variable alone. And they already gave you the one variable alone. We didn't have to do anything to get that, right? And then slide that variable from the first one line, which that's supposed to say line 1, into line 2's y. Okay, so let's do that. Negative 4x distribute. 5 times 3x is 15x. 5 times negative 15 is negative 75 equals negative 31. So negative 4x plus 15x is 11x, which I put over here. Minus 75 is negative 31. I'm wanting to get the x variable by itself, so I'm going to add 75 and add 75 to both sides, which that cancels, and I get 11x equals 44. Ah, that's very nice, because 11 is a factor of 44. So now I divide both sides by 11, and x is 4. So let's go over here. X is 4. X is 4. So now what do? I take that 4 and I slide it into the first equation. So 4 times 3 is 12. 12, take away 15 is negative 3. So negative 3 is y. Now, I've already got a solution. I checked that solution in the first line already. I'm not going to do anything with it again, but I have to check that solution back into the second line. So let's check. Negative 4 times 4. Negative 4x is negative 4 times 4 is negative 16. And 5 times a negative 3 is a negative 15 equals a negative 31, and that's true. So 4, negative 3 solves both lines, and 4, negative 3 is the solution. Okay, so let's try number 4 and see if we can do that one here. All right, so here we have another system. It says for each ordered pair, determine whether it is a solution of the system. So we have ordered pairs down here, and we have our system right here. Now, if it is a solution, then negative 3, negative 4 will fit into both equations and make them true. So yes, we have to try each point into every equation. So let's try negative 3, negative 4. We plug in, so we have 4. We're going to have the x right there. We'll make that a negative 3 for this point. Minus 5. We'll make the y right here, and the y is negative 4 for this point, equals 8. So we check it out. Negative 12 plus, because it's a negative 5 times a negative 4, so it's a plus 20, is 8. Say, oh, that is correct. So we know that this point works with this one. So now we're going to look at the second equation, which is negative 3x plus 2y equals 1. Okay, so the x is negative 3 that we're trying, and the y is negative 4. Okay, so this is 9 minus 8 is 1, and that is also true. So we say negative 3, negative 4 is a solution to this system. Now, that is the only one that I'm expecting, because this is a line and this is a line. Okay, and they're not only going to have one place where they coincide unless they happen to be the same line, which I do not think they are. So let's try the others. We're going to erase the x, and we're going to erase this first one here, and we're going to erase the x and the y, and erase this one here. Okay, so let's go and do the second point. Negative 6, 2. Negative 6, 2, negative 6, 2. Okay, so this is negative 24 minus 10 is negative 34. That one doesn't work. I don't even need to check the next one. This is a no. It has to work in both, and it doesn't work in the first one. So I don't need to check the second one. So we're going to take this one out, and this one out, this one out, this one out. Get rid of that, get rid of that. Okay, so now we're going to check the next point. 3, 5. 3, 5. 3, 5. Okay, so now we have 12. Minus 25 is not 8, so this one is a no. Okay, so then we're going to go and do the last point, which is a 2, 0. 2, 0, 2, 0. 8 take away 5. 8 take away 0 is 8, so it works in the first one, but negative 6 plus 0 is not 1, so this is another no. So remember what I said, since these are two lines, and we had already found the solution on the very first try, remember a system of lines, if it has one solution, is going to cross at one point and have one solution. All right, so it says for each ordered pair, determine whether it is a solution to 4x minus 7y equals 19. Okay, so we're going to take out the x, take out the y, put in my parentheses, and plug in 9, 6. 9, 6. 36 minus 42 is not 19, so the first one is a no. Okay, erase, erase, get rid of these. Okay, the next one, negative 4, negative 5, negative 16, positive 35. Okay, so 35 take away 16. The 15 take away the 6 is 9. So yes, this one works. We erase, we erase. We try. Next one. Negative 6 and 2. 4 times negative 6 is negative 24. Minus 14 more. That is not going to be 19. So that will be a no. And the last one. Is a 3 and a negative 1. It's a 12 plus 7 is 19, and that one does work, so we'll say yes. And we will. Okay, so we are on problem, this was number 5, we're on problem number 6 now, even though it's not labeled. So 6 on your sheet that you're working on. Shown below are the scatter plots for 4 data sets. Answer the questions that follow. Okay, so it says choose the data set that shows clustering. Well, clustering is bunching all together. Wouldn't you say that this one up here is showing clustering? Okay, it's bunching up together. So we're going to say the data in set 2, figure 2, shows clustering. Now it says choose the data sets that have outliers. Okay, at outliers it says set, so we can choose 2 of them, and that's good because that looks like it's an outlier. Remember, a point that doesn't look like it belongs in with the rest of the scheme here. So we would say 1 and 3. So figure 1 and 3 have outliers. Okay, now let's talk just a minute about correlation. Correlation. Because you're talking about a little bit here. We'll talk about it more later, but this is so easy. I just want to bring it up here. Correlation. This one right here has a negative correlation because it's going down. Okay? It has a negative slope. If it were a line, it would be a negative slope. So it has a negative correlation. So that's figure 1. Has a negative correlation. That's easy. It's going down. Figures 3 and 4 have a positive correlation because from left to right, they're going up. So this would be a positive correlation or a positive slope to that line that would go through there. Okay? All right, so now it says the table below shows the age and the height for each of 7 trees. Okay, create a scatter plot for the data. All you have to do is plot those points, right? So let's plot 5, 6. 5 up, let's see, 6 is right there. So we got to go over to 5 and plot a point. 8, 9. So 8, and we got to go up to 9 and plot a point. 9, 11. We go over to 9 and we go up to 11 and plot a point. 10, 8. 10, 8. Go over to 10 and go up to 8. Okay, 11, 10, 11, 10, 13, 13, 14, 12, 'That's all there is to it. Now, let's do a line of best fit just for kicks here. If we're going to make a line of best fit, which you'll be asked to do, is we're going to see if we can make a line that would approximate that data, kind of go through the middle of that data. Okay, so I'm going to say, oh, well, let's just go right through the middle of that data. And then I would just carry the line down. Okay, so in this one, since this is age and height, wouldn't it make sense that if we had a 0 age, it would be 0 height? So our line of best fit would go through 0, 0, wouldn't it? And it does. Okay, so here we have another one to analyze. Okay, it says shown below are the scatter plots of 4 data sets. Answer the questions that follow. Okay, this is very scattered. This is a negative correlation. This is nonlinear, isn't it? It's not even a line. And this one is a positive correlation. It's more scattered out than that other one. Which data set appears to show a negative linear relationship or a negative correlation between its 2 variables? Well, if it's negative, it's going down. It's this one. So figure 2 is the answer. Okay, which data set appears to show a positive linear relationship? Okay, this one's not a line. This one's positive. It's going up. And it is pretty linear. It's not perfect, but it is a positive linear relationship. So that would be data set 4. Which data set appears to show no relationship? Well, that's the one that's very scattered. So that's going to be figure 1. Okay, which data set appears to show a nonlinear? It's not a line. And that is figure 3. Okay, the data points in the scatter plot below show the amount of time spent watching television and the amount of time spent doing homework last week by each of 24 high school students. Draw the line of best fit for these data points. It doesn't have to be the exact line of best fit. Just draw your best approximation. Okay, so I'm just going to get a different color. And I'm going to try to go straight through those points. And when you're trying to do a line of best fit, you kind of want to try to get about as many of the data points on each side of the line. So I'm going to maybe start right about there. And I'm going to do my best to try to get about as many data points on each side of the line. It's not going to be perfect. Okay, later on when you get into a higher math, you will learn how to do a perfect line of best fit. Okay, the table below shows the amount of rainfall and the temperature at noon in each of 6 cities. Okay, so then it says create a scatter plot for the data. We've already done that. So 2:14 would be right there. 5:10 would be right there. 7:9 will be right there. 8:6 will be right here. Oops. 11:5 will be right there. And 12:3 will be right there. Hopefully I got all those right. Okay. I think so. Wait, that's an 8. 8:6. Oh, that's a 5:10. I made a mistake. So I'm not seeing real great this morning. This is a little too little for me. 5:10. There's 5. There's 10. There's 7. Ooh, I missed another point. Just not seeing well. Okay, maybe I did it right now. Okay, these are so tiny that I'm having a hard time seeing them. That's what happens when your eyes get old. Okay, so that's 8, 6, and 11, 5. Okay, maybe we got them right now. And they do look like more of a line now, don't they? All right, so we are done with your little video blurb for 6.3 and 6.4. So now what you're going to do is finish this. If you have to go back to the video, finish it up. And this you will turn in. But before you turn it in, you will use it as a pattern to do the 10 problems on 6.3 and 6.4 homework. Okay, that will be what will be due on Monday, is the 6.63 homework, 6.3, 6.4 homework that is already posted on Teams. It's 10 problems that you're going to use this as a model to help you do. I would have the video showing you these problems while you're doing those problems at home. Okay, and then you're going to turn both exercises into me on Monday. I don't want you to turn it into me today. I want you to turn it into me Monday because I want you to keep your worksheet while you are doing your homework to help you with anything from the worksheet. That will help. Then on Monday, you will take the 6.3 and 6.4 quiz. We've dropped it back and we're doing everything together right now because we've gotten to the point in the material that everybody is struggling and needing to do every quiz, and so we're just doing them together. So 6.3 and 6.4 quiz will be on Monday. On Monday, we will cover 6.5 all together, and we will take the 6.5 quiz. And then we will have everything pulled together so that you can take the 6.5 test. You'll be ready to take that. Okay, so that's kind of an overview of where we're going. This is Mrs. A, and may God bless your day.